Those of you who were at Bangkok saw this slide already. Our mission is leading collaboration in the ARM ecosystem. This is why Linaro exists. We're trying to help all of the ARM vendors work together and deliver software that enables everybody in the community to create amazing products. We see some trends going on in the industry. Our initial focus 6 years ago when we started was in the mobile space. But today, ARM has penetrated every single market segment across the IT space. Everything from simple sensors and controllers that could be out in a field measuring water condensation, all the way to the data center itself and building servers that are going to power the next generation of the web. And it's not just ARM in everything, it's open source software everywhere and in every piece of equipment that we use. And product developers across this spectrum are looking for multi-vendor device, gateway, and cloud software solutions. However, there is a problem, and we all share this problem across the industry, and I'm calling it today the embedded software problem. And to explain this problem, I first want to talk about servers briefly. ARM servers just have to work. They have to work using existing established industry standards. The software for servers is incredibly complex. And in order to make it work, it relies on the hardware meeting certain standards. And ARM, the Linaro Enterprise Group, LEG, and the ARM server vendors have worked really hard to make this happen. You can take an ARM server and just plug it into a data center, and it will just work. That is how easy it has to be. Then we can start innovating and differentiating and creating products that do amazing things with the ARM architecture. But if it's not based on standards and it doesn't run the same software on different hardware, it will not work. And the developer cloud, which we're going to talk about later today, demonstrates enterprise open source software end-to-end running on multiple ARM server vendor products. Same software, same distribution, running on different vendors' hardware. But the embedded world is different. The embedded world, every single vendor, and there are hundreds of them, have proprietary tools. Some of them require Windows. Some of them require old versions of Windows. Some of them require Linux. Some of them require Macs. There are hundreds, literally, of operating systems. There are multiple implementations of the same standards. There are vendors who support the same operating system on their own products, but they support different versions across their product range. There are silos everywhere. Why can't embedded devices just work as well? What does it take to have the ability to pick and choose across the range of vendors in the embedded world? Linaro, our DNA is to work together on software platforms that are needed by everyone. Where it's non-differentiating, where it doesn't add value, there's no point in all of us doing it again and again and again. We need to share the cost of open source software development. We need to do the engineering once, not hundreds of times. And then we can all compete on our value add and our differentiation. And we can use our engineering resource to focus on what makes us different, not on just doing the same thing again and again. That's an incredible waste of effort. And as we move into a world of connected devices, this becomes even more important. These devices have to just work together. If they don't, if we have to spend time in plug fests making them work together because they're all based on different software, we're going to fail. And these devices have to be secure. Security is not an optional feature, and it's not a feature that everybody can develop. We don't have enough security experts in the world to cope with the number of products we have. And these products need to be maintained over their lifetime without having to return them to the factory, or worse still, throw them away because they've got a bug that can't be fixed. So what do we need to do? Well, first, we need to come together. We need to collaborate on this problem. We need to leverage open source software. We need to build platforms that we can all work on. And security and over the wire or over the air updates, they're not an option. And they're not value adding. Everybody has to have them. And we're going to maintain products by keeping them updated. It's not that hard a concept. Certain product segments, if you think about something like healthcare, there are very strict legislation. It can take years to get a product ready to go to market. And then that product has to be supported over its lifetime. But if it's connected, it might have a security flaw. We might need to fix it in the future. We have to face that. And we have to be able to, at any time, roll that fix out. If we can do that, we improve security, we lower cost, and we enable delivery of new functionality. There's a company that does this rather well. And this company brings out a new product every year. But not only that, they make sure that the product they released 4 years ago also gets the software update. And in fact, they're continuously updating the product for 4 years. Now, to some vendors, this doesn't seem like a very good idea. Why would anybody buy my new product if I can just upgrade my old one? Well, this company I'm talking about doesn't seem to have a problem. Every time they bring out a new product, they can't make enough. And why is that? It's because they're delivering an excellent user experience and they're delivering new functionality and new innovation. And all of those phones that people replace, they're going to somebody else. They're not being thrown away because they're old. They're being used for that product lifetime of 4+ years. Some people still have the original iPhone and are still using it. So this is extending product life. It's good for the environment, but it's still allowing innovation. So why don't we aim to do this with open source software for all connected devices? Why don't we create a platform that enables this for the smallest sensor to the most complex device? That's what I think we need to do. In order to get there, we've been working for a while now on a concept of a reference platform. And this is an end-to-end open source reference software platform that is not about a particular distribution. It's distribution agnostic. It includes firmware, it includes kernel, it includes distribution, middleware, and sample applications, and it's built on upstream technology. And our goals for this program is product quality. It's not just for developers. Our goals are to get the quality of these products to where they can be used directly in end-user products. Now, we're not trying to commoditize everybody, but we're trying to create a platform that everybody can use as the starting point for their products. And those platforms have to have certain features built in. Security, over-the-air updates. Just build them into the platform, and then we don't have to worry about them. If I'm a light bulb manufacturer, I don't have to worry about the security software because it's already built into the core platform. As long as I don't change it, it should just work. And coming soon, you'll see IoT device, networking, digital home, IoT gateway reference platforms, and a lot more focus on testing, validation, and quality. And we're going to be introducing a reference platform certified program for 96 boards to enable those boards to be used in test farms that we can control to do a very high level of testing on these reference platforms. So I'd like to do a very quick tour over the next 30 minutes of the Linaro segment groups. And first, I'm very pleased today to actually publicly launch Light, that we first started talking about at the last Connect. Light, the Linaro IoT and Embedded segment group, is now the 5th segment group that Linaro has started. We're publicly launching it today with an end-to-end focus on the Internet of Things. And initial members include ARM, Canonical, Huawei, NXP, RDA, Red Hat, Spreadtrum, ST, TI, and ZTE. Some of our existing members and some new. And I can tell you that this is not the end of the list. We have a number of companies who we're in discussions with that we expect to join Light in the very near future, and my personal expectation is that Light will very shortly become one of our largest groups. Very exciting. Before I talk a little bit about what we've been doing in Light to date, even though we haven't announced it until today, I'm going to ask Mark Hambleton, the ARM Director of Software Engineering for the Systems and Software Group, to come up and give you a little bit of ARM's perspective on Embedded and Light. Mark.
Thank you, George. Unlike some people, I don't need a bowl of M&Ms to get me on stage. I actually need this picture. People from ARM have seen me do a presentation based around this one before. This is a cut-down version, so hopefully everybody will stay awake through it. So it goes a bit like this. So science fiction, I'm sure we're all aware of it, can give us some really clear views of what's likely to happen in the future, plays on our hopes and fears in general. In this film from 1984, The Terminator, we see a robot that kind of goes rogue, but is actually obeying its programming. In the sequel, we see that robot reboot, and it boots into an operating system that looks actually a lot like Linux. When you actually look, as Thomas Mulgard did, sat in the front row, you see that it's running an operating system whose version is 4.1.15. Now, for the Linux geeks in the audience, that version was released in December last year. Okay, so this robot was from 2029. That software was from 2015. So that robot was running 14-year-old software. Is it any wonder that John Connor could reprogram that thing and send it back to protect his mother? Anybody see a problem with that? So, as you all know, I'm getting old gracefully. So this is actually a picture of a circular knitting machine that I worked on probably 20, 25 years ago. I know there's at least one person in the audience that's seen this because he was part of the team. That software today, that device will be running the same software we wrote 20 years ago. Still working, not updated, still with all the same security flaws. It's a safety critical machine, right? It has many, many hundreds of pairs of knitting needles. Doesn't sound that fatal, but trust me, when it goes wrong, it does go wrong quite spectacularly. Now, modern embedded looks a bit different. You know, designed for safety updates in the field on a continual basis. But that's not necessarily true of everything that we see. People have seen this slide before, notice that there's a teddy bear there. There are a lot of embedded devices that are becoming, you know, smart, but have the same problems as that knitting machine, running stale software with security flaws that haven't been updated and are actually not possible to update. So today's requirements for embedded are actually subtly different to those requirements 20 years ago. Security needs to be at the heart of every embedded device. And for security to be correct, you actually need to build in maintainability so that you can update when you find flaws, not if, right? I'm a software guy. I will admit that there are occasionally bugs in software, occasionally. And as we get from that robot that we saw a few minutes ago, safety is becoming more and more important in every embedded device that we build, whether it be an actuation device or just something that sat on your wrist. okay? So we need to make sure that we cover all three of those bases. And maintainability, the box in the middle, is the thing that underpins all three. Okay, so what does a Fitbit and a Tesla have in common? Well, it's easy. Both of them were designed from the start with updatability and service delivery at their heart, okay? Why is that important? Well, they're actually a good example of what we now expect to see in every embedded product. A lifetime of updates, just as George was mentioning earlier, from that smartphone model, a service offering updates to the features as well. It's what gets users bought into that product line, which is why that's important. OEMs are going to start to demand that of every single one of our embedded devices in the future. So it's not just going to be the Teslas of this world that are going to provide you this evolving experience. It's going to be everything. Why is it important? Continuous updates of software cost. So the harder it is to maintain the code that's running on those devices, the more your costs go up, and the less viable your products will be. So I hope you're all aware that the ARM architecture is not just about the Cortex-A, right? Cortex-A is what we find in our smartphones, in our servers. It's optimized for those rich operating systems, high-performance computers at its best. But there are actually three profiles in the ARM architecture. The ARM Cortex-A profile, as I've just said, the R profile, which is optimized for real-time safety-critical devices, so real high-performance real-time systems. And then there's the Cortex-M, optimized for low-power, very, very small devices. I think we're all familiar with the Cortex-A, but let's take a little bit of a look at the Cortex-R, or the ARM V8R architecture. So V8R is built on V7R. That's quite convenient. It builds on a long legacy of real-time processors, but V8R is important because it introduces bare metal hypervisors into those real-time cores, enabling you to separate safety-critical processing from your rest of the world applications. And those eagle-eyed people amongst you will have noticed that we released the Cortex-R32 last week, right? That's our first V8R profile core. I encourage you to go and have a look. We've also just introduced V8M, ARM V8M, for real-time deterministic embedded processing. Important thing about this architecture release is that we're actually building in Trustzone now to make deploying security in your embedded devices easier. So we've now got the extra security features of Trustzone embedded into small energy-sipping devices. Why are we talking about that? Well, as I said, common software is vital. Any bit of differentiation is actually cost, right? So every single line of code that you write that's specific to your product is actually cost first. Oh, some music playing. So only differentiate where there's value has got to be the key message that we're presenting here. So what I really mean here is not use Linux. Most people think using common software is use Linux. What I mean is look really carefully at all of the operating systems that you're planning to use. Look at the hardware that's supported out of the box in those operating systems, and think really carefully before you do something else, right? Because every single line of code you have to write is going to cost you in the end. So use standard configurations. So ARM have got a number of standard configurations that we're pushing, and there are also other platforms based on the ARM architecture that have got good upstream support. Look at what they're doing and see if that meets your needs. What we've really got to do is make sure that it's easy for software developers to land software on your hardware, because that's going to be the thing, the key to controlling your costs. But the other thing is actually collaborating on the development of that software is vital to controlling your software costs, right? And that's why we think Light is a really important collaboration vehicle for the ARM architecture. Linaro's delivered great value in the other segments that they've been operating in, so LEG, LNG, LHG, LNG. And we think Light is the natural successor, or the natural evolution of Linaro. So we welcome the idea that Linaro is now working in the Cortex-A space and the Cortex-M space in the embedded segment, and maybe sometime in the future Cortex-R, who knows? But what I want everybody to think in this room is how they would answer these questions. How are we building in security to the heart of the products that we're working on? And that's something that George has already mentioned here. How are we lowering our product lifecycle costs? Key here is using maintainable software. And how are you addressing the growing needs of functional safety? That's why we've started talking about the new Cortex-R, V8R announcements. And that's it from me. Thank you very much.
Thanks very much indeed, Mark. So I want to talk a little bit about the progress we've made so far in Light and our plans. And we've been fortunate enough that some of our existing members have already contributed some assignee engineers, enabling us to start the Light effort. Matt Locke is the director of the Light group. And also Linaro, some of you may have noticed, has joined the Zephyr project, which is a Linux Foundation project. We've joined it as a platinum member alongside Intel, Synopsys, and NXP. We are using Zephyr as a neutral delivery vehicle for a lot of the technology that we're doing. Kumar Gala, the tech lead for Light, is already maintaining ARM architecture in Zephyr, and Linaro has started making upstream contributions to this project. Within Light, you will find there's steering committee meetings this week. There are also sessions, and we are exploring the needs of the members and the community in smart devices, so high-end Cortex-Ms running Zephyr or Mbed and so on, or other operating systems, and low-end Cortex-As running Linux. There's a concentration here on connectivity, and perhaps, depending on the application, small UIs. And then, obviously, there's a focus on small footprint and low power consumption. Also today, we're introducing the 96 board's IoT Edition. This is a small form factor board, tiny size, minimum mandatory functionality, a Cortex-M MCU, minimum M0, with a certain minimum in terms of memory and flash, and a USB port for power and communications. We're also introducing, as well as the existing standard 96 boards expansion connector, which is a 1.8 volt signal level connector, we're introducing a new connector for microcontrollers on processes that require 3.3 or higher voltage. And there are two profiles for the IoT Edition and two board sizes, both for Cortex-RM and then for Cortex-A. So I encourage you to review this specification, provide comments. It's on the website today. And we're pretty excited by what companies can do with this. In fact, we've already started. We've worked with a partner, Seed, in China to develop a board that we are using for our own internal purposes already. This uses a ST Micro Cortex M4 MCU. We have a Bluetooth on board, which is a Nordic controller with a chip antenna. And we're going to show you this board a little bit later. And in fact, anybody who wants one who is here today will be able to pick one up later. But please make sure you only pick it up if you're going to use it. I'm going to now ask Yang to come up in a little while, but we're just going to show some video from him in the meantime.
The reason why we did this board is that we believe this is actually a good demonstration of how easy it is to design a 96 boards hardware with all sorts of different types of MCUs, which we know there are many to come. So 96 boards initiative is the first and the only SoC independent specification out there. It is designed with in mind to allow the developers to have access to the latest and greatest SoC technology with the standard form factor. Now we're pushing out 96 board IoT specification apart from enterprise and the consumer edition. And also we are seeing a large participation from the community who are designing mezzanines and software solution, around 96 boards.
Okay, so it's not only Cortex-M. I mentioned that the 96 board specification also allowed for Cortex-A, and very shortly you will be able to buy from the Orange Pi organization a product called Orange Pi i96. This is interesting because it has a low-end Cortex-A 32-bit device, but it has integrated 2 gigabytes of RAM and 4 gigabytes of flash, and it has Wi-Fi and a CSI camera interface on it. We can't wait to see what developers are going to do with this in the areas of vision and recognition systems and robotics and so on. And the amazing thing about this board is its price, which is going to be less than $10. So we're looking forward to seeing what you all do with that. Finally, Light is, as I said at the beginning, working end to end. One of the things that we've particularly looked at with members and potential members of Light is around IoT gateways. And today, the gateway market is complex. There are many, many gateways. There's kind of one gateway per client product. And that's clearly ludicrous. All of these gateways talk ultimately to the same wireless standards or a multiplicity of wireless standards, but they're all doing the same thing. But you need to cater for each vendor's own proprietary protocols. And David Rustling, our CTO, Matt Locke, and others in the Light project, we have a vision in Linaro for a universal gateway that uses containers to segment the different protocols and the different vendor software and effectively have a universal gateway concept that will connect to multiple devices and connect them back for both industrial and consumer applications. So one of the projects that Light is taking on is the IoT Gateway. We are planning to develop technology to deliver a reference gateway project, and I encourage you to attend the relevant sessions later this week if this is something that is of interest to you. I'm particularly pleased that 2 of our major partners, Canonical and Red Hat, are joining this project because this is clearly an area of interest for the whole industry. Okay, so that's Light. I now want to move on to LMG, the Linaro Mobile Group. And LMG quietly in the background has been actually growing. We have an increasing number of member engineers assigned to LMG. And Tom Gall has led the team that's doing a lot of work on AOSP optimization. We are seeing typically 10 to 15% performance improvement over AOSP in the member AOSP-based builds called MLCR. Those optimizations are fed back into AOSP for the next version of Android. We also talked last time about how the High-Key 96 boards product is now supported in the AOSP tree. That has made life a lot easier for developers because they're now able to use a community board to work on Android in adjacent markets. I'm also really pleased to see not only older chips, but also the very latest mobile chips being put onto 96 boards so that they are accessible to LMG and to the rest of the community. And as an example, MediaTek recently introduced the X20 board, which is a 10-core, 3-cluster Cortex-A7253 with Mali T880, so fast graphics. And they're going to talk more about that tomorrow. New initiatives in LMG include ART Performance, Codec 2.0, looking at open fastpath networking for the kernel, and some effort that's been going on for a while now within Linaro as a collaboration between the Office of the CTO and LMG on reducing vendor out-of-tree patches, both in kernel and user space. And to talk a little bit about this, I'm going to ask Rob Herring from the CTO office to come up and show you some of the things that he's been doing.
Thank you, George.
Hi, Rob.
So I've been working on the Android HAL consolidation initiative with the LMG team. It's a broadly defined project with a small team on it at the moment. We've been looking at and working on graphics and display, as well as a single device target to support multiple platforms. The single device target is approach we used on the kernel for kernel consolidation, so we're trying to reuse that approach here. We knew that with Android devices, it's very important to have the tunability for capability, and we also want to have the all-in-one capability. So we needed a configuration system, and for that we used Kconfig, which started in the kernel, is now used in a variety of projects like U-Boot and Zephyr. So let me show you that. So I have my device target here. I just run menu config. So you can select device type. Right now it's tablet or TV. Variety of image configuration options, as well as what hardware support you want to enable. So that's the Kconfig. Next, I'm going to show one of the targets we've been using, which is an x86 build of our target running QEMU. This is all mainline kernel QEMU and Android. So one of the neat features here I'm using of QEMU is USB device pass-through. So I have a USB Wi-Fi dongle on my laptop here. I've assigned it into the guest. And I can go and test Wi-Fi in my VM. There's the access points. This also uses a thing called Virgil, which is host-based graphics acceleration assigned into the VM. This has been very useful for enabling people outside of Linaro that are doing work on explicit sync fences. This is the last feature needed in DRM graphics for replacing Android's atomic display framework. So next up, I have Dragon Board 410 right here. I wanted to do some sensor work on it, but Dragon Board doesn't have sensors. Fortunately, we have this sensor mezzanine board and a bunch of Grove modules available. So I picked an InvenSense 9250 Grove module. Now we have screen rotation. This is also running open source graphics with Fredrino and Mesa GL. Next up, I have the high keyboard running the same board configuration as the Dragon Board 410. It's using Mali graphics driver instead. It's also running a 4.8 kernel with the Android common patch set forward ported to 4.8 that Amit Pundir has been working on. in preparation of a probable 4.9 common kernel. And then finally here, I have a Nexus 7 that's running 4.8 kernel with about 50 patches on top of it. John Stoltz has been working on. And it's also using Fujino graphics. Same device configuration, different build because it's 32-bit ARM. So that's the completion of the whirlwind tour of boards. Slides. For more information, there's a URL at the bottom. And we'll be talking about what's coming next for this project Thursday at the AOSP mini-conf. And you can also see these demos in person on Friday.
Thanks very much, Rob. So this is actually really impressive because I think it's really going to help developers take AOSP out into adjacent markets and to be able to narrow the gap between what's going on in AOSP and be able to use a common build system to build Android for different targets is something that I think is going to become really valuable. So some great work going on there. Thanks, Rob. So now I want to move on to the Digital Home Group. Continuing our lightning tour. The Digital Home Group has been working under Mark Rogotsky on the Comcast RDK platform, where Linaro has made significant contributions, and also on the AOSP and Android TV platforms. We're also in discussions with SAFT, the China government organization that's working on tvOS in China, to see how Linaro and the Linaro Chinese members can help on the development and evolution of that platform into the open source community. Most of the work in LHG has been around security solutions, working on using the open source OPTEE, Trusted Execution Environment for Trustzone, both on Linux and on Android, and developing applications that use that technology, including key management and DRM using Microsoft PlayReady and Widevine. LHG does publish the Open SDK. This is a collection of technologies for security, device management, and video and multimedia pipeline processing. So anybody who's interested in this area, I encourage you to go and visit the sessions and drop in on the LHG hacking room. Today, I'm very pleased that Mstar are announcing a digital home platform which is called Carver. It's the second 96 boards Enterprise Edition digital home version. It's a quad-core A53 using their brand new K7 set-top box SoC. And interestingly, it includes 4K video, both input and output. Has 10 base T and gigabit Ethernet, multiple USBs and smart card and tuner interface. This is the first time this board has been shown. You can see it at the show, and we're expecting that Mstar are going to ship this in volume, hopefully by the end of the year. Mark has a few words to say, I think.
LHG is going to have an exciting week at LAS16. We have a lot of very interesting presentations and demos lined up using 96 boards with our latest media framework solutions and security solutions. 96 boards is very important to LHG. It affords us the opportunity to use low-cost, readily available hardware such that we can promote and advance our media framework solutions and security solutions for our members. You know, we're very excited about the new Kava board from Mstar. It's a quad-core A53 with a high-end Mali 820 GPU. It actually allows us to do both 4K video input as well as output via HDMI and digital audio. It's going to be a very exciting platform for LHG to be able to realize a lot of the reference platform work that we are doing.
Thanks, Mark. But we thought today what we'd do is actually show you a demonstration of another 96 boards Enterprise Edition digital home version. This was announced a few weeks ago by HiSilicon, uses a HiSilicon set-top box SoC, also Quad A53, and includes gigabit Ethernet, Wi-Fi, and Bluetooth support, as well as smart card and tuner. What's interesting, and the board is here, I'm going to be very careful with it because it's powered up, and we're about to show it to you. This board is available today from AliExpress. It can ship anywhere in the world, and it's only $79, which is pretty impressive. To help me demonstrate it, I'm going to ask Yang Zhang, head of 96 Boards Group, to come and show you what it can do. Yang. Hold on one moment. Just changing some cables up here. Okay, switch over. Okay, over to you. So what Yang is doing is he's using a TV remote to talk to the Poplar board. And as you can see, it's an AOS TV implementation running a range of applications. He's going to try his hand at a video game. But just to make things interesting, he's going to use his mobile phone, his Android mobile phone, connected over Wi-Fi as the gaming controller, because we left the real one somewhere else. So let's see how he does. What I wanted to do was make it so that he couldn't see what was going on, but we've given him a monitor in front of him. So he's made the connection with Wi-Fi, and he's now off and running. He's actually pretty good at this. No, shouldn't have said that. All right, well, this is pretty amazing for a $79 board, right? And there's plenty of things you can do with it. We're really excited to have this board to actually start working on open source software for the digital home market. Thanks very much. Okay, can we switch back? Okay, so that's Poplar and the digital home group. So let's move on. Networking group. The Linaro networking group has been doing amazing work around ODP, the Open Data Plane software-defined data plane. And this allows SoC vendors to leverage proprietary data plane acceleration hardware in their SoC. Really pleased that LNG made the first LTS release called Monarch last month. And we're starting now to work and see deployment of that release into networking applications and networking infrastructure across the industry. But we're not stopping there. The next release is being worked on already, Tiger Moth, and that includes applications transparent acceleration and virtual networking acceleration. There is also a new additional initiative in LNG being discussed this week on time-sensitive networking. This is networking, this affects networking actually in the Linux kernel, and is particularly interesting to the automotive, industrial, and media markets. So if you're interested in this area, I encourage you to attend the LNG meetings and sessions. There's some really interesting things going on, and we hope that you have a good week looking at the networking group activities. They'll also be demonstrating on Friday. So moving finally on to the enterprise group, I talked earlier about ARM servers needing to just work. And it's amazing to see the progress that's been going on, not only in LEG, but across the industry on ARM servers. They really are now starting to come to the stage where as servers come into the market, the software is going to be ready for more and more applications. Linaro and its partners have been working hard, collaborating on all of these open source projects, and they've culminated in the delivery of the Enterprise Reference Platform. The last version was released in June, the next version will be released in December, and this is not only the firmware and support for the distributions, but it's also building all of these projects on top like OpenStack, Ceph, and Docker, and so on. The developer cloud has 50 servers running already. Demand is exceeding supply, and Martin's going to talk a little bit about that in a minute. We have that running in Austin, in Texas, and Cambridge, and we're bringing up China as soon as we possibly can. I have to say a big thank you to all of our members, because that wouldn't be possible if our members didn't provide us the hardware. The main lead projects for LEG are software-defined infrastructure, including OpenStack, and also the big data projects that we've been working on over the last year. But there's a lot of new activity in LEG as well to expand the software that's available on ARM servers and to optimize it further. And big focus on enterprise testing and validation. And also identification of two particular areas of interest for the ARM architecture, one being storage, where there's going to be more effort and work jointly on Ceph project, and also specific interest in the future for ARM in the HPC market. Some of you will have seen Fujitsu's announcement of building the next generation supercomputer based on ARM, and HPC is of significant interest to the ARM vendors. So there is discussions. We're starting up an HPC special interest group in LEG. If that's of interest to you, please talk to Martin and the LEG team. Martin would like to make a few comments.
So our enterprise group is, we focus in on everything around the server and the data center. So that's everything from the boot architecture, ACPI, UEFI, moving up the stack. We provide a reference platform with the Linux kernel for ARM servers. And then we go a little higher up the stack into cloud and big data technologies. So we launched the developer cloud about 6 months ago. And with that, the demand was overwhelming. So we had a lot of good reception initially. What we're launching now today is a way for you to have a self-service portal to be able to go and have cloud instances. And instead of giving you a dedicated machine, we're giving you a project, which gives you a number of CPUs, amount of memory, and disk storage. The thing about the developer cloud is we run this on ARM64 machines. So that's not just the compute instances, but also the controllers that actually control OpenStack. And that OpenStack is part of our reference platform that we provide for any user, any individual, any company to download and install. And we do this in a couple of ways. You can go to a website, you can actually download the binary bits. But more importantly, we also offer a reference architecture for OpenStack so that you can go ahead and grab that reference architecture. With Ansible, you can then deploy your own OpenStack-based cloud based on the reference platform.
Thanks, Martin. And what I'd like to do is ask Martin and Herma to come up and show you some of the work that we've been doing on the developer cloud. Martin, Herma.
It's on. All right, are we getting set up? And we're switched over. All right, so, we started this about 6 months ago with the developer cloud, and we would provide a machine to you. You would send in an email form. We would then talk to you about what you wanted. You would get that machine. You would tell us what OS you wanted to have. So it's very brittle, very static. So this is the next step in what we're doing. And this is the new interface that you'd be able to go and get OpenStack, ARM64 cloud instances. So here we're just demonstrating a way that you go and sign up. As you can see, this is a paid for service. We do have discount voucher codes for the community. So we'll just sort of walk through that. And while we're walking through, one of the things you'll notice here is it's a Linaro Cloud small project. So the difference now is instead of you being able to get one machine, we're giving you a project space, and we'll show you the portal here in a minute. Project space means you get a number of virtual CPUs, certain amount of memory, and a certain amount of disk storage. And then it's up to you and your teams that are going to do test development and porting for ARM64 for you to be able to decide how you're going to carve that up. So that's what we're doing. You're going through and applying. So you can see it's just a very simple form for you to be able to go through and do this. And you buy it now. Right now, the way we're doing this is t-shirt sizing, small. medium, and large. So it all depends on what your needs are, if you're an individual developer or if you're a company. All right, so we have we've got a portal. This is a self-service portal here. Saw a little bit more than we thought first. That's okay. So I'm Bob, and here I'm going to go log in. And for those of you who've used OpenStack in the past, you'll see that this is very, very familiar with a little bit of theming. But you get your portal, and it gives you a dashboard that tells you what you have available. So for this one here, this is a large instance. I think we give 6 cores, about 24 gig of memory, and some drives. You can choose to then create 1 server, or 6, or 2, or 4, or whatever it is that you're looking to do. So we have some images here. A note about images. We provide a default number of images that you can pick from right away. CentOS and Debian, which is part of our reference platform, and then several others as well. So let's go ahead and pick one. Which should we do? All right, so yeah, you know what? We got sponsored by Canonical, so we'll boot a Xennial one. And Hema's going to walk through and just sort of select the process. The difference here is that you are in full control of your developer cloud versus before asking for a machine and getting it. The other difference is that if you decide you have your own Linux distribution that you want to upload as a cloud image, you're free to do so. All right, so again, this is all based off of the Enterprise Reference Platform that George talked about. The OpenStack that we use is also based on the Enterprise Reference Platform that we have. These are output from the lead projects that we developed inside of the Enterprise group. We have a talk on Wednesday around the sessions for OpenStack and Ceph that we're using for this. We have a big data session as well on Wednesday, and then the firmware mini summit for ACPI and UEFI that this all runs on Tuesday. That's it.
Wow. What's amazing about this is there's a couple of things we can do with it. We are using all of this to validate everything we're doing. We're doing it ourselves. We're eating our own dog food. We're making this work so that we find problems before our partners and our vendors. And all of our members are helping us in this process. And the software to do all this, we just live in front of you started up an instance. We purchased an instance, and started it up live in front of you on an ARM server. And all of the software to do this is available to the whole community. You can use this as the starting point for building your own ARM cloud server. So we're really excited about this, and we're going to continue to work on it and continue to try and find the problems and enable third-party software vendors to build their software on the developer cloud, getting access to all of our member hardware. For example, recently, the MongoDB team used the developer cloud to do validation and support ARM64 in MongoDB, so that's great. So what have I done today? I've given you this lightning tour across the segment groups. I've talked about open source collaborative engineering, how important it is. I've painted the vision of how we can create a embedded platform that builds in security, builds in over the air, and can be used by the whole industry. Because if we don't do this together, we're not going to succeed. We're going to lose a lot of momentum behind what we can do in the IoT world. We've talked about AOSP mobile optimization and community board support, and the launch of 96 boards for the digital home space, which we think is going to really help get software and developers excited about working on TV media applications. Open Data Plane is a key initiative for Linaro. Huge amount of work's gone into this across our member companies, and we're really excited it's rolling out. And the Enterprise Reference Platform is pulling together and now starting to look at the deployment aspects of ARM servers. So we're really moving now into the world where ARM servers are starting to be able to be put into real applications. None of this would be possible without the support of our 32 members. We in Linaro now have over 300 engineers working on open source projects. And we have 150 of our own employees, we have 94 member assignees, and we have 89 member engineers. And I couldn't be prouder of the work that you're all achieving. Congratulations. Before I go, there's one thing that we just couldn't wait to show you. There's a small team in Linaro who've been working on the initial technology for the IoT Reference Platform that we want to release a developer preview of by the end of this year. But we're so excited by what they're doing that we wanted to give you a little preview of some of the work that they've been doing. In order to do that, I'm going to ask Tyler and Ricardo to come onto the stage and talk a little bit about what they've been up to.
Great. Thanks, George.
Thanks.
So we want this demo to build on everything that was discussed today in the keynote. So an end-to-end IoT demo, essentially. So what we have in front of us here, we've got two boards, our carbon board that was announced and another IoT board based on the 96 board form factor. These are deployed in the field. They're not connected to any sort of test harness. They're simply powered. What we have here is a IoT gateway, which is a Dragon Board 410C. It talks Bluetooth low energy to these boards and uses 6 low-pan WAN to get IPv6 addressing so it can talk to our cloud service. The next piece we have here is our test harness. This is remotely connected to our Lava Cloud instance and will run our tests that you'll see here in a moment. So we've got all these pieces here. We're going to demonstrate the whole thing end to end. Go ahead, George.
So what we have here is a 4-screen display. The test farm is sitting here. Here you have the devices under test. They are flashing LEDs. Good Hello World application. And here is, on the left-hand side, is the gateway. Those boards under test, the only wire is a power supply wire. They're not connected to anything. This is a live demonstration. We've never done it with 400 Bluetooth devices in the audience. So we'll see how we go. But those devices are purely interfacing to the rest of the world through Bluetooth. We're also simulating the work environment we've used to develop this demo, where Ricardo, based in Brazil, has been working on his side of the demo, one end of the world, and Tyler has been working in America at the other end of the world on the cloud services that we're demonstrating today. On the bottom left is the test harness, and then we have the laptops on the right. So I'm going to hand back to Tyler to show you what he's up to.
Okay, so let's pretend I'm some sort of developer, right? And we've got these devices that are deployed in the field, and the customer reports an issue saying, you know, it's great that these devices are working, but there's no way to know when they're actually connected to the gateway because I forgot to put a status LED on. So I'm going to patch the IoT Reference Platform, which is based on Zephyr, and I'm going to push it into our CI system. And so this demo is going to be in 2 phases. The first phase is the continuous integration phase, which is what I'll show you. And then we are going to deploy it to a device deployment for phase 2, and Ricardo's going to take over and actually do an over-the-air update. So this builds on security, maintainability, and safety. Safety that we're able to check our change before we push it, maintainability that we can issue an update, and we're going to show you the security part because all the images are signed. So let's get started, shall we? So this is the patch. It's trivial, but we should still test it anyways. So let's apply it to our source code. Okay, we've got it applied. Now let's push it. So I'm going to push the, to something we call Git CI. So this is our branch, Linaro master. Now this looks pretty normal, except now we've started a CI loop. So the whole workflow is now Git driven. So I'm going to hand it back over to George, and he's going to explain a little bit more about what's going on.
So what's happening here is that Tyler is checked out the IoT Reference Platform, he's modified code, and he's locally building and testing his changes to the application. He's then Git pushed that into the cloud service that we're using to do several things. That cloud service is completely scalable. It has a set of build servers that are controlling the builds. It has a set of Lava virtual machine servers that are virtually running instances of the application and testing them in a virtual environment. And it also has access to test farms that can be situated anywhere around the world. This is truly scalable. It's a cloud-based system. It can be federated across installations in any of your company facilities anywhere to work on maintaining and keeping products up to date. So the products are being automatically tested. Once that's completed, Assuming the test results are positive, if they're not, you have to go back to square one, we have a signed production image is being sent over to the deployment cloud servers. Now, today we're actually demonstrating real signed images. We're running out of time. If we had time, we'd actually create an unsigned image and show you that that didn't work. You'll have to trust me on that one. We're actually going to send a signed image because the firmware on the microcontroller is going to check that signed image before it will run it. So if this demo doesn't work, it's because somebody interfered with the code. The next thing we're going to do, once we've got that to the cloud deployment, is we're actually going to deploy that change over the air from the cloud server, which can be situated anywhere in the world, can be on any service, and we're going to take it through the Dragon Board 410 gateway and onto the deployment boards. Now, this requires a number of different services that we've developed. The first is Lava that we're using for test automation. So that is interfacing to both virtual and to real hardware. We're using Git for code storage and coordination of builds. And we're using a custom builder system that we've built tuned to build the Zephyr platform. This is 3 times faster than using a developer laptop system, and we think we've got more to do. But the nice thing about this is it's completely scalable. We've got a cloud server for storing artifacts, and then we're using an IoT device deployment system. Now today, we're demonstrating this using an open source project called Hawkbit. That's an Apache project for IoT device deployment. For production, we would expect you to choose from a number of commercial platforms, including Embed Cloud, or IBM Bluemix, or AWS, or Alibaba, and so on. So I think it's time we found out how that testing is going, Tyler. What do you think?
Absolutely.
Okay, so can we switch back?
So far good, so good. We're in the green. The tests up here are the core Zephyr tests. So these are the kernel and the crypto test cases. Below here, we've had our production images built for the nitrogen board and the carbon board, and we've actually got the tests. So we've tested our production application. Everything is green. It took us 3 minutes and 31 seconds from a Git push. And that's hassle-free, very, very fast. Now the images have been built and tested. We've deployed them to Hawkbit automatically. And so I'm going to turn this over to my colleague Ricardo here for the deployment.
So as we do that, I would just sort of say again, this development process and what you're seeing on stage, none of this is local. Well, the boards are actually local and the farm's here. But this was developed across the world. The farm was in one place, developer in another, and that's how this process works. You're actually seeing this live, but the deployment server is somewhere in the cloud. So I'm now going to move to Ricardo. Tell us what you're doing.
Right. So we got this new feature that was applied. Tyler, there was a test already. You see here, like in the deployment management system, that the images are already in place. So Tyler, can you confirm just like the version that you're using?
Yeah. So the hash should be 902270.
Right. So there you go. So you see here that you have the unsigned and signed images already set. So let's try, because of time, let's try simply pick up the first one in here. Drag and drop and apply this. So this will basically set up the configuration deployment system in a way that the board can probe the server and actually find out if there's an update that needs to apply, download, and so on and so forth, and perform the actual upgrade. So we could do the unsigned in here as well. And the difference that the board would refuse, since we have that security check as part of the update process. So let's go and do the other, sign it on the other board. So as George said, everything is over network. So we're probably expecting a few issues. One of the things that I noticed in here, it seems that Carbon is not connected to the server. So it also like shows it up in here because the board is always like pinging and connected to the server. So I'm just gonna ask if Tyler can just restart Carbon and see if everything will work. So, and now we're just basically waiting the boards to communicate with the server and download and flash the process. So this is going to take a little bit. So meanwhile, I'll just go back to George so we can explain more about the architecture.
So what's happening here is now the deployment request has been given to the server. The server sits in the cloud, and it's doing a lot of complex stuff. It's going to take a little while. But the point is it's scalable. It's not just to one device. This could be to 100,000 or 1 million devices. And it just waits for the devices to talk, deploys, and then you get statistics back telling you how many devices were deployed, was it successful, and all of the things that you expect to see out of a IoT device management system. So the services that I've just explained, I should also talk a little bit about, while we're just waiting for that to deploy, I should also explain a little bit about how this is working. We have built here the basics of what we want to deliver as the IoT Reference Platform. This is based on a common bootloader that works across different vendor MCUs, and reference boot sequence and fallback and rollback so that we can roll back any bad implementations. And it's a common, generic, over-the-air architecture and implementation. Today, we're using a dual bank approach, whether you have a single bank SoC hardware or whether you have hardware that supports dual bank, this architecture will work in both cases. And the main application is an open source module that has an open source module that we've created that's responsible for receiving and writing the new image. We're also testing the image integrity through authentication when we actually run it on the target device. Now, one of the next steps is to enable full encryption so that the IoT data transfers from the device to the sensor, whatever, will be completely encrypted, and also the over-the-air update itself will also be encrypted. That will be in the release that we do in December. Seems like we're making some progress here, so I'm going to switch back to the devices and we'll take a look at them. And wow, one of them is already updated. So we now have a blue LED. Well done, guys. Your code was good. Test works. So rather than just waiting, which will be like paint dry, we'll get back to the presentation. So we were really excited to get this into your hands because this has been a very small team in Linaro. They've worked very hard to make this happen, but we want to see what you all can do with it. So today we're making available carbon boards to anybody who wants them. And you can pick them up at registration after lunchtime, anytime after lunchtime. Before you do, please fill in the form at that web address. It's the correct address, linaro.co/getcarbon. And you just have to sort of fill in one sentence as to what you're going to use it for, and then we'll give you one. The software that's available for this is all the software you've seen here on the client side, the software to build this, the software to do the updating. We're running an IPv6 stack using Zephyr's 6LoWPAN networking, and we're doing that over Bluetooth for this demo. We're showing signing and authentication, and that's included in the software build that we're providing. HTTP client libraries. And then we also, based on some work that Matt's group have been doing in Light, are providing not only C, but also MicroPython and JavaScript as applications development languages. And of course, the simple flashing LED application with the working blue LED now. So let's see how we're doing.
One of the images already deployed, as George said. The other one, just verifying here. So you had like a few connectivity issues, so just like restarting and probing and getting the image again. So it's going to take a little bit more time. I know that we're short in time, but I also want to say that we are just testing with 2 boards in here. Like we're using the gateway in here to access just 2, but we could actually provide access to more. And we're using 6LoWPAN over Bluetooth. So they have like real IPv6 and expose it to whatever service that you want. And on Friday, we're going to demonstrate with more devices and hopefully more kind of and types of devices as well. So we can provide the same thing, but describing the entire scenario, doing like a proper rollout, which would mean like updating several machines at the same time.
Okay, so before we wrap up, what I'd like to do is just ask Tyler to talk a little bit about what he's doing with gitci.com. So Tyler, if I give you...
Thanks, George. So if you guys go to getci.com right now, we have a little bit of information out here. So essentially what we've built is a container orchestration system that provides CI services. And as George said, it's fully scalable in the sense that we can handle a lot of load. We've embraced the micro architecture when we were building this out. So everything's got an API contract and everything's replicated. So what we'd like to have you guys do is, if you're working with a Carbon and Zephyr source throughout the week, go ahead and give it a try. So it kind of, gives you, the site gives you a little bit of information about, what we can provide. So essentially, we can give you developer tests. We can run the developer tests in Zephyr for you, provide the results on a Git push. It's hassle-free, right? We wanted to make it as easy as possible, as simple as just doing a Git push to get your code tested. So if you go down to the bottom of this page, you can put your email in to keep in touch if you're interested about new features or have feedback for us, but you can also obtain access. So what you'll do is you'll create a username and add your pub key, and then you'll have access to the Git server that we provide, and you just push your Zephyr code there and it'll be automatically tested. So testing is just a Git push away, as we like to say. So thank you.
All right, so thanks very much, guys. That's amazing. I mean, this is the beginning of something. We wanted to show you some of the technology that we're working on. We're really excited by this. The amazing thing about this is this piece of software is completely portable. It's been built with the same tools, it's the same image, and with configuration of the firmware image, it's running on completely different manufacturer MCUs. And we did this independently of those MCU vendors. So what we're wanting to do is encourage the industry to come around this kind of platform and help us develop it. And we think that this will help us to realize the vision that I laid out to you earlier of making it easier to build the kind of devices that we need for the IoT of the future. Thank you very much for your time. Going to hand now back to Joe.